Yeah, so like we said on Monday, okay, that the partial pivoting technique, okay, Gaussian pivoting technique is limited, okay, with regards to having a leading coefficient or a pivotal value being equal to what? Zero, okay. Once that happens, the program written is going to end up with infinity because the pivots are used in estimating the multipliers. Good. So hence the need for another method, which is the scale pivoting. And we also did mention that the scale pivoting technique, okay, the scale pivoting techniques help us to avoid a minimal value of the of a pivot, okay. Yeah, because it will always select the optimal value of your allies, okay. I will say to obtain the li, what you do is first you find the absolute value of the leading coefficient, okay, divided by the maximum absolute of the maximum value in what? Each row, okay. So for L1 is going to be the leading coefficient in row 1 absolute over the SI, which is the maximum value in row 1, okay. And then once again you find the absolute value. Very good. Then in our explanations on Monday, we also said that to obtain at any step, okay, to select a pivot, you have to find your allies, okay. Good. But taking into consideration that our scales S, okay, are only estimated once. The SI, which is the S1, the maximum value in each row, are estimated once, okay. So S1 is 7 here, S2 was 7, S3 is 3, and then S4 is 17, okay. Good. Whereas in the first selection for our optimal li, okay, we use the coefficient. So this will be 2 for row 1, L1 will be 2 over 4, okay. L1 is what? 2 over S1, which is 7, okay. L2 is the leading coefficient, absolute of the leading coefficient, which is 4 over 7, okay. L3 is absolute of the leading coefficient, which is 2 over the maximum value, there is 3, and then L4 is what? Leading coefficient is what? 6 over what? Over 17, okay. Now we select the index which maximizes, okay, the li, and obviously the fraction 2 over 3, okay, like we said, okay, is the biggest what? Index, okay, which means that row 3 will be the best option, okay, as the pivoting row, which implies that we're going to make use of this first element as the pivot, okay. And we also did mention that the computer didn't need to rearrange the rows, okay, but we needed to rearrange for the purpose, okay, of understanding. So what we did in class, in the previous class, was to bring row 3 to the top, okay. So this is what we did. So we said the initial row 3 was brought to the top, okay. So this is row 3, and then this was row 1, okay. Then we brought row 2 down, okay, and then we had row 4, okay, down here, okay. Then we apply the pivoting formula, okay, for the reduction. So now that this is our pivot, we're going to do the reduction. So the first element, which is A11 new. Okay, A11 new becomes what? Becomes 2, will become 2 minus what? 2 over 2, okay, times 2, which is 0, and then A1 2, okay, new is equal to what? Is equals to minus 1, is equals to negative 1 times 2 over 2 is 1, so we'll maintain 1 times the value on top. Okay, sorry, this should be negative, this should be minus. Okay, so we have negative 1, okay, minus negative 1, which will give us negative 2. Okay, then we have A13 new, A13 new will be equal to, that's 3 minus 1 times 1, okay, A minus 1 times 1 will give us what? 3 minus 1, which is equals to what? Which is equals to 2. Okay. Then the next one will be A14 new equals to 7. Okay, 7 minus, we have 1 times 3. Okay, so we get, just a minute. Yeah, so that gives us 4. Okay. Yeah, then the last one will be B2 new. B2 new is equal to 15. Okay, 15 minus 1 times 7. Okay, so that will be 15 minus 7, which is equals to 8. Okay, so then we populate, that gives us 0, negative 2, 2, 4, and 8 here. Okay, good. And you do same for the next row. Okay, so for the next row, let's pick the first element. So that will be A21. Okay, so A21 new will be what? Will be 4. Okay, minus our multiplier is what? Coefficient over pivot. So we have 4 over what? Over pivot is 2. Okay, times 2. Times 2, which equals to 0. Which equals to 0. The next one will be A22. Okay, A22 new is going to be, that's 4. Okay, minus, I think it's going to be the same thing, 4 over 2. Okay, 4 over 2, no, the one on top is 1. Okay, so we got 4 minus 2, which is equals to 2. Then we have A 2, 3 new gives us what? Gives us 0 minus 4 over 2 is 2. Okay, times 1. Okay, times 1 will give us what? Negative 2. Will give you negative 2. Gives us negative 2. Okay, then we have A2 for new is equals to what? 7 minus 2. 7 minus 2 times what? Sorry, let me just undo this. So this 2 should be in bracket instead. So 7 minus 2 times what? Times 3. So that will be 7 minus 6, which is equals to 1. Okay, that should be equal to 1. Okay. Then finally we have B3, or instead B2. B2 new is what? It's 11. It's 11 minus 2 times 7. Okay. 11 minus 2 times 7. So that's 11 minus 14, which will give us what? Negative 3. Okay. So that gives us the results we have here: 2, 2, negative 2, 1, and negative 3. Okay. Then finally, for the next row, you do same. Okay. With a new multiplier, that should give us 0, 2, 1, 8, and 10. Okay. I'm sure you can do that. I'm sure everybody can do that by now. Class, I hope you can all do that, the third reduction. Hello? I hope you can all do the third reduction. I have muted you. I hope you can all do the third reduction.
Yes, sir.
Okay, good. Yeah. So now let's look at the next step in the process. Yeah, so once we get to this point, the next thing to do is to select the next pivot. Okay. Now there are 3 rows here. You don't automatically assume that this second row, second column should be the next pivot. No, you have to select. Okay. So in selecting, use the coefficient. So for L1 is what? Like we said, the absolute of the leading coefficient. So 2 over the original scale. Okay. The original S1, this is row 1. So original S1, okay, was 7. Okay, was 7. And then original S2 was what? Was also 7. And then the original S3, the scales, like I told you, are computed only once. The scales are computed only once. It's your LR you calculate every time you are about selecting a pivot. So that will be 2 over 7. L2 is what? L2 is 7 over what? Oh, sorry, that's 2 over 7. Then L3 is what? L3 is also 2 over 17. Okay, good. So we look for the optimal value. Okay, so optimal value 2 over 7, 2 over 7. They are the same. So we can either use row 1, okay, this row 1 here, okay, for the next reduction, or use row 2 for the next reduction. Okay, but as it looks, once row 1 is already on top, we will just make use of what? Row 1. Okay, good. So that is how we decide on the next pivot. Now let's do the pivoting, okay, the elimination. So that is going to be this, our new pivot. Okay, so let's not forget this is row 2, and then this is row 4. Okay, good. So A2 1, just a minute. So A2 2 new is going to be what? 2 minus what? Leading coefficient 2 over what? Pivot, which is -2, okay, times value on top, which is -2, -2. So -2 cancels out this, and then 2 minus 2 is equal to 0. Next one is A23. A23 new is what? It's -2 minus -2 over 2 over -2 is -1. So we use that. So -1 times what? -1 times 2. Okay. Yeah, so we have this is going to be +2 here, and this -2, so we have 0. Then we have A24 new is equals to, we have 1, okay, minus -1, -1, okay, times what? Times 4, which will give us 1 plus 4, which is equals to what? Equals 5. Okay, then next one will be B2 new is what? -3, minus what? -1, okay, times 8, okay, which will give us what? +8 here, -3, which is going to be 5, +5. Okay, so that's it for the next row. Okay, good. Then for this last row here, we're using the same, okay, the same pivot. So that gives us, we have A42 new, okay, A42 new is equals to 2 minus, we have 2 over -2, okay, times -2, okay, which will be equal to 0. Then we have A43 new will give us, we got that is 1 minus -1, okay, times what? Times 2. So this gives us +2. That's +2 plus 1 is 3. The next one we have from A44 new will give us 8 minus -1 minus 1, okay, times 4. So we have +4. 8 plus 4 should give us 12. Then finally we have B4. So B4 new gives us, we have 10 minus -1, -1 times, okay, times 8, which gives us +8 plus 10 is 18. Okay, good. So we can then populate our matrix, okay, with the new estimated values. Okay, you have this matrix. Let me clear the screen. Okay, so this gives us the matrix as we see over here. Okay, so as explained last week, okay, this time we have an echelon. Um, we have an upper triangular matrix. It's just a matter of interchanging row 3. Sorry, they should be row 2 and row 4. Okay, so by interchanging row 2 and row 4, we have our upper triangular matrix. Okay, then we can rewrite the matrix, okay, in this form as a system of equations, and then use backward substitution to solve for it. Clearly, we can see that Z is equals to 1. Okay, Z is equals to 1. Okay, and 1Z is equals to 1. Then it means we have 12 times 1, which is 12. Okay, we take to the other side. That should give us what? That should give us 6. And then 3y is equals to 6, which implies that y, okay, it implies that y is equals to 2. Very well. So we have z equals to 1, y equals to 2. So that will give us 4 plus 4, which is equals to what? Which is equal to 8. Okay, that gives us 8. Okay, let's be very sure of this first. Okay, so this 12, 6, that's 2. This is 4. Yeah, this is 4. This is also going to be 4. Okay, so goes to the other side, that will be 0. X is going to be 0. So we have x equals to 0. And finally, we put that here. So x is 0, y is 2, z is 1. Okay, so we have 2 plus 1 is 3. We cross over, that will be 4. Okay, so 2w is equals to 4, which implies that w is also equals to what? It's also equal to 2. Okay, so that gives us the solution of the system using what? The scaled pivoting G method. Okay, any questions? Any questions so far? Any questions so far? It's it's Bami delay on this platform.
Yes, sir.
Oh, Bami delay, you've been hiding. You should have let me know that you were on the.
No, I'm not.
How are you?
I'm fine, sir.
Good. I've missed your class so much.
Oh,
I said I've missed this class. I didn't know it was your class I was teaching.
oh,
Yes.
okay.
It's today when I was marking my assignment, then I saw Pamidile. I said, is this my daughter on the platform? Okay, very well. So let me take your questions if you have any before I move on to the next topic. If there are any questions you can ask before I move on. Justice, do you have a question for me?
No, I don't have any question for now.
Okay.
I don't have any question for now. But I'll just say that meet up your son. You say your daughter is here, meet up your son.
Yes, that's what I'm saying. I've missed this class. This was my favorite class, you know.
Oh, yeah.
Yeah, this was one of my favorite class. Bami Delay and I've forgotten the names. There was uh, this Cameroonian lady. and the
Yeah,
guys in
yeah, yeah.
front. Yeah, I've forgotten the names. It's only Bamidele I remember anyway. But I know this was my favorite class. Yeah. Okay. Yeah. So let's
Mm.
move on to the next topic, which is using the Gauss-Jordan technique. Okay. So we're going to look at the Gauss-Jordan technique. Um, okay. Okay. So the Gauss-Jordan technique is also a very simple method. Okay. And the good thing about this method is if it's well done, then by the time you finish the transformation, you have your determinant, your inverse of the matrix, in addition to the solution of the system. Okay, so basically Gauss-Jordan is a technique which will convert, okay, the system as an augmented system with the identity element into the form determinant, okay, of the matrix A here, okay, times the identity solution and inverse of the matrix A, okay, where I is the identity and identity matrix and A inverse is the inverse and B is the solution of the system. Okay, and here we are using the factorization method together with the normal Gaussian elimination approach. Okay, good. So what we do first is, if you're given any system of equation, what you do is you rewrite the augmented form, okay, which is a normal A, okay, A, B form. Then you add, okay, the identity matrix to the system. Hmm? Good. Then what you do is you are now going to use GE and factorization to change the first matrix into an identity matrix. Okay, so you transform the first matrix into an identity matrix. By the time you obtain identity matrix, you have your solution matrix at this point. Okay, you should have your solution matrix. And then the last matrix here is going to be the inverse of the matrix A. And the factorized coefficient here is the determinant. Okay, the product of the factors gives you the determinant of the matrix A. Good. That's the lovely thing about this technique. Okay, so let's solve an example. Just take note of the transformation whilst we solve an example. Good. So as our first example, we want to try this simple 2x2 system. Want to try this simple 2x2 system. Just study the system a bit. Or just look at it briefly and then I'll do the explanation. Give me a minute. Yeah, I'm back. So what we're saying here is if you're given the system of equation, regardless of the dimension of the system, okay, just write in the form of the augmented matrix with the identity. Okay, so that is A, B, and then we have the identity system here. Okay, yeah, and like we said, the objective is to convert A into the objective is to convert A into identity matrix. Okay, good. And to do that, we employ the Gaussian elimination as well as factorization. Okay, so step one, what do you, yeah, and let me say, in reducing A to identity matrix, then it means that we are supposed to obtain the matrix 1, 1, 0, 0, okay? In the first component here, okay? That is what we mean by changing A to what? To I, okay? Good. So if that is the case, then it means that the elements on the diagonal, whatever be the case, we'll have to do some factorization to get them into the form of 1, right? And then once we've obtained 1 here, we can use the 1 to, eliminate, okay, whatever value we have in the other diagonal here. You understand? So we can use first we can use this 1 here to eliminate this to 0. Then we factorize and then make this also 1, okay? And then we can use that also to reduce whatever value we have here to 0, okay? Using the Gaussian elimination method, okay? Which is very, very simple. Good. So let's give it a try. Good. So step 1, we will like this A11 to become 1, okay? And to make that 1, it means we have to factorize. So the operation we're going to have here is to factorize 3 from what? From row 1. We're going to factorize 3 from row 1. I'm going to zoom in so that we can follow step by step. Okay, so the first step is to factorize 3 from the first row. Okay, and once we do that, okay, we're going to have 3 outside the brackets. Okay, so this is what we're going to have as a result. Okay, so we have 3 outside the bracket. Okay, and then within you have 3 over 3, 2 over 3, 13 over 3, 1 over 3, 0 over 3. Okay, good. Then you simplify that. Okay, so when we simplify, we're going to get 3, 1, 2 over 3, 13 over 3, 1 over 3, and 0. Okay, and then once we obtain it, like we said, the next thing to do is to reduce this to 0. Okay, this form must go to 0. Okay, so we just employ either the pivoting or the G method, okay, for reduction. And in doing so, you can have the operation, okay, row 2 minus 4 times of row 1. Okay, row 2 minus 4 times of row 1. We want to eliminate this. We want to make it 0. So if we have the linear combination 4 minus 4 times 1, we're going to get this to be 0. Okay, so that is why we have this operation here. Or like I said, you could have used a pivoting. If you're using pivoting, this is your pivot. Okay, so then it's going to be what? Then the operation is going to be what? A21. Okay, A21 new is equals to minus what? A21 new is equals to what? A21, okay, which is no need for formulas. Let me just write. This will be 4 minus what? Your multiplier, which is 4 over 1. Okay, 4 over 1 times 1. 4 over 1 times what? Times 1, which is basically the same as in the case of the G. Okay, good. So which will give you 0. Okay, the next one remains the same. So A 2 new will be what? 3 minus 4. Okay, 3 minus 4 times what? Times 2 over 3. Okay, good. Which will give you 8 over 3. And here we have 9 over 3. So 9 over 3, this will be 9 over 3 minus what? Minus 8. Okay, which will give us 1 over 3. Okay, good. Then you do same across the row. Okay, you do same across the row till you get to the last value. Don't forget. Okay, good. So once you do this calculation, okay, good, we'll come to this point. Okay, so we have 1, just a minute. Okay, so you have 0, 1 over 3, you have 2 over 3, negative 1, 4 over 3, and 1. Then, like we said, the objective is to have our diagonals to be 1 and 1. Okay, so which means that we need to factorize this also to become 1. Yeah, so you bring out 1 over 3. Okay, yeah, so we factorize 1 over 3 as the next operation. Okay, so that is going to be, the next operation is going to be what? We factorize what? 1 over 3 from what? From row 2. Okay, we're going to factorize 1 over 3 from row 2. And then once we do that, okay, this is what we're going to get. Yeah, this is what we're going to get. Okay, so 1 over 3 from row 2 give us this side to be 1. 1 over 3 means you're actually going to multiply 2 by 3. Okay, so you multiply here by 3. Once we have 1 over 3 out, then you are multiplying through the row by 3. So we have 3 times 1 over 3, 1. 2 over 3 times 3 will give us what? 2. Negative 4 over 3 times 3 will give us negative 4. And then 1 times 3 will give you what? 3. Okay, then it's very clear that the next operation will be to convert this to 0. We want to eliminate this to 0 or put it to 0. Okay, and the only way we can do that is to use this diagonal. Okay, this diagonal value. Okay, and once again, that will be based on a G approach. Okay, good. So the next operation we're going to conduct will be what? Will be R1. Okay, row 1 minus 2 times R2 over 3. Okay, yeah, so once you multiply row 2 by 2 over 3, and you have the linear combination of row 1 and then minus 2 over 3 times of R2. Okay, we should get the operation, this operation here. Okay, we're going to get your 1 over 3 should still be here. Okay, don't forget. So we should get 1, 1, 0, 0. And once we do these other calculations too, okay, you should get here to be what? To be 3. Yeah, for those of you who be wondering, okay, so this is R1 is what? 13 over 3. okay, minus 2 over 3 times R2. This is R2, which is 2. Okay, so that's 2. Okay, so that gives us 13 over 3 minus what? Minus 4 over 3. Okay, LCM gives you what? LCM gives you 3. Okay, 13 minus 4 is what? 9. Okay, which